Let's investigate the electric charge spin and weak isospin in the decay of the B quark. So first let's look at the electric charge. Now, of course, the B quark is going to decay into a C quark. And so initially we start with an electric charge on the D quark of minus 1/3, since the contribution of the rishons is minus 1/3, 0, and 0. And the contribution on the boson zeros is 0 because each of the components provide opposite electric charges. Now the W plus is emitted and it carries away a charge of minus 1, since its components have the electric charge of minus 1/3 and minus 2/3. The boson 0 makes no contribution to the electric charge, and neither does the vector boson. And we have the opposite electric charges on the components of the anti-B. And if we look at the decay product of the C quark, we will see that the electric charge on the boson plus, of course, is 1/3 and 2/3, which is 1/3. And combined with the minus 1/3 on the D quark, we then have 2/3 on the C quark. So now let's look at the spin quantum. And so the spin on the B quark, initially, we have on the generic D a 1/2 and a 1/2 and a minus 1/2 for a sum of 1/2 spin. And we have opposite spins on the components of the two boson zeros, so they contribute nothing to the spin, and we have a spin of 1/2, which predicts that there will be no weak isospin on the B quark. And let's look at the emitted W boson. The emitted W boson, we look on the boson minus and boson 0 components. Again, we have opposite values on the components of those, but we have the vector boson, which is carrying away a spin of 1. And so that gives the boson minus, the W minus a spin of 1 is indicated by the standard model. And then the decay product of the C quark, we can see we have the opposite values on the boson plus, but then we have minus 1/2 plus 1/2 and minus 1/2 on the rishons of the D quark, and so we have a minus 1/2 spin on the D quark, which predicts that it should have a weak isospin value. Now we have the opposite spin quanta on the anti-B as to what we had on the B quark. Next we will look at the weak isospin. And so, look then at the weak isospin. First starting with the B quark, we see that the weak isospin values on the D quark are plus 1/6, minus 1/3, and plus 1/6, which gives us a sum of 0, which we expected since it's a right-handed particle. And the values on the two boson zeros are opposite, so contributes nothing to the weak isospin. We go to the W plus, which has been emitted. We can first look at boson minus, and we see that we have a weak isospin of minus 1/3 and minus 2/3, which gives us a minus 1. The boson 0 has opposite values, so it contributes nothing to the weak isospin, but the vector boson has a weak isospin of plus 1/2. When that is summed with the boson minus, we have a weak isospin of minus 1/2 being carried away. But we started with a weak isospin of 0. So let's look at our C-quark. On the C-quark, we have 1/3 and plus 2/3 on the boson plus for a weak isospin of 1. And on the generic D-quark, we have plus 1/6, minus 1/3, and minus 1/3, which gives us a minus 1/2. Sum with the 1 will give us a plus 1/2, and then, which is the correct weak isospin, which the standard model predicts for the left-handed C-quark, and summed with the minus 1/2 weak isospin on the W that's carried away on the W plus, we have our original isospin of 0. And of course, we start with opposite values of weak isospin on the anti-B, and when it combines with the W, then the minus 1/2 isospin that it carries will then become a minus 1 isospin for this right-handed C-quark, anti-C-quark, which is the correct weak isospin predicted for a right-handed anti-C-quark by the standard model.